Hi, my name is Andy Ravenna, and I'm a technical trainer for SAS Institute. Today I would like to talk to you about how to perform end-to-end machine learning in SAS Model Studio. Let's start by giving you a very quick introduction into the analytics lifecycle and machine learning pipelines. The analytics lifecycle consists of three phases. We start in the data phase, where we get to access our data and begin to explore our data. There's the discovery phase, where we get to have fun building models on our data. And finally, in the deployment phase, we pick a champion model and put it into production. Model Studio, available in SAS Viya, is an integrated visual environment that gives us a whole suite of analytics tools. It allows us to perform end-to-end data mining, text analytics, and forecasting. Model Studio is the common interface that includes the following SAS solutions: SAS Visual Data Mining and Machine Learning, SAS Visual Forecasting, and SAS Visual Text Analytics. The data that we are going to be using during the demonstration is taken from a large financial service. We are going to keep the data dictionary mainly as self-study, and you can find all the details in the included PDF that is available with this presentation. But let me tell you just a few things so that when we jump into the demonstration, the data will make sense to you. The data has been anonymized and transformed. The financial company offers things like home equity lines of credit, automobile loans, and other credit instruments. Our data includes a bank campaign that ran for 6 months, where both direct and indirect promotions were offered. While we have lots of information on our customers and their activity, our primary target variable is binary. It's simply an indication of whether or not a customer made a purchase during the campaign. Now that we have the highlights of the data, let's get right into my demonstration. In this demonstration, what I'd like to do is perform that end-to-end analytics lifecycle for you. We'll start by loading some data into Viya. Then we're going to build some models using pipelines in Model Studio. We will even integrate some open source models as well as build model interpretability plots. We will then pick a champion model and show you how to manage and deploy it. Let's get started. Okay, I've opened up a Chrome browser and I'm ready to get started with SAS Viya. So I'm going to navigate to SAS Drive. We'll talk about what SAS Drive is in just a minute. In the meantime, I'm going to use the default credentials to log in. We're going to be asked if we'd like to opt into assumable groups. We're going to answer no, because you and I don't need to act like an administrator today, and we don't need all those extra tables up in memory. So this is SAS Drive. You want to think of SAS Drive as sort of like your home page for all of your SAS Viya applications. This is where you would go to get started. We're going to go to this upper left-hand corner Applications menu and open it up. These are all of the Viya applications that are available to us. Your menu might look a little bit different depending on what you've got licensed and available. You and I are interested in building models today, so we're going to select Build Models, which is going to take us directly into SAS Model Studio. In SAS Model Studio, we're going to click on the New Project button to start up a brand new project. And the name of the project that we're going to call this is Model Studio Project. And before we continue, one of the things I want to do is give us just a little bit more real estate. So I'm going to go into the Chrome browser and I'm going to zoom us into full screen mode. And that just gives us a little bit more real estate, which is kind of nice, so we can see everything. The type of project that this is data mining and machine learning. We also need to add data into our project. So let's click on the Browse button. And you'll notice we're on the Available tab, and there are no tables that are loaded into memory. So we don't have anything that we can use. We could go over to the Data Sources tab, where there's actually a server available to us, and maybe we have a table stored there. But it turns out you and I want to go over to the Import tab, because our table happens to be on our local machine. So we're going to go to Local Files and Local File, and we're going to go to the correct subdirectory to get the data table bank part _ how. I'm going to click on Open, and then one of the options that I'm going to select is that I would like to replace the file just in case there happens to be an old table here on SAS Viya that we would like to overwrite. I'm going to click on Import Item, and what that is doing is taking that SAS table and actually loading it up into memory so that we can take advantage of it on SAS Viya using these in-memory analytics. You can see that the table was imported successfully. That's a good thing. We're happy about that. Let's go back over to the Available tab, and you'll notice there is the SAS table that we just loaded into memory. I can actually select it to get all kinds of great information about that table, including how many columns there are and how many rows there are. There's also information about all the different columns, and we could even take a sample of the data and examine it so we could see what some of the values are. I'm going to click on the OK button to close the Choose Data window. So now we've got a project, we've got a table. One of the other things that I'd like to take advantage of is one of these advanced options. You can see that there are several, and if you take our pipelines course, which lasts for 2 days, we teach you about all the different options that are available here. I'm going to move down to the Partition Data option, and what we're going to do is we're going to change the partition that is the default so that now we have 70% training, 30% validation, and we do not want a third test partition. So we're only going to have 2 partitions. We're going to have training and validation. I'm going to click on Save, and I think that's all I want to do before we're ready to get started. So I'm going to click on Save again in the New Project window, and that's going to take me directly into Model Studio. When Model Studio opens, it's going to open up on the Data tab. The Data tab has all kinds of great metadata about the columns that are in the table that we are using. Now, Model Studio is going to automatically make some decisions about the metadata and how it's going to be used in the project. But one of the things that we're going to notice is we get a little message that says you must assign a variable with a role of target in order to run a pipeline. So before we can build any pipelines, we need a target. So what I'm going to do is I'm going to select our binary target, B_target. You might remember that's going to be that target variable that is an indicator of whether a customer made a purchase or not. And then we're going to come over to roles, and we are going to choose that as my target. And now I've identified to Model Studio that B_target is in fact going to be my target variable. Okay, now we're ready to build some pipelines. So I'm going to move from the Data tab over to the Pipelines tab. And we have a default pipeline that has started with just a data node. So I'm going to do a right mouse button click on the data node to add in a child node. I'm going to go into Data Mining Preprocessing, and I'm going to select an imputation node. By default, with the imputation node, a missing class input is going to be replaced with the mode value, and a missing interval input is going to be replaced with the average. After the imputation node, we're going to add another node. So I'm going to do another right mouse button click, add a child node, data mine preprocessing, and this time we're going to add in a variable selection node. So the variable selection node has several defaults, and we're going to change just a couple of those. The first thing that we're going to do is we're going to change the combination criteria from selected by at least one to selected by a majority. Now, right now, just the fast supervised selection method is going to be used. We're actually going to turn on the linear regression selection, and let me minimize that, as well as the decision tree selection. Let me minimize that. So now we're going to use a total of 3 methods to try to decide if an input should be selected to be used in the model. And in order for that input to be included, it has to be selected by a majority of those 3 methods, which basically means 2 out of 3. Okay, so now we've done a little bit of data pre-processing, and we're ready to add in a model. I'm going to do a right mouse button selection on variable selection. We're going to add a child node. We're going to go into the supervised learning methods, and we are going to add in a neural network. And we are just going to go with all the defaults. Now, I've shown you that there is an easy way to add in different nodes by using the mouse. I also want to show you that over on the left-hand side of my Model Studio project, there's a nodes pane. And when we open up those nodes, you're going to see the same nodes that are available by using the mouse clicks. Only here, what we can do, for example, is we can drag and drop items. Some people like to use the mouse, some people actually like to drag and drop. So here's what we're going to do. We're going to add in a second model onto this pipeline. And so I'm going to go over to the supervised learning nodes, and I'm going to grab a forest. And notice what's kind of nice is as you mouse over each of these nodes, you get a little bit of pop-up help. I'm going to grab this forest and I'm going to drag it and drop it and add it on the data node. And so you're going to see that's going to be placed directly into the pipeline. And at the bottom of the pipeline, we automatically get a model comparison node. So this allows me to compare all of the different models that are in this particular pipeline. Now I'm going to go ahead and close up my nodes so we get a little bit more real estate, and I'm going to run this pipeline. And while this pipeline is running, I want to talk to you a little bit about why we decided to perform imputation and variable selection before my neural network, but we did not do that with the forest. Well, it turns out that the neural network, like many of the prediction models, use something called complete case analysis, which means that if one value is missing from an input, the entire row gets eliminated. It doesn't even use that case in building the model. So we're going to perform imputation for the neural network so that we can not lose, hopefully, any of the data. Also, neural network does not have any way of performing variable selection. So if you want any sort of narrowing down of that list of inputs as you start to build your models, you're going to have to perform specifically a variable selection before you get into the neural network. Now, forests are different because forests are made up of a whole bunch of decision trees. And both forests and decision trees have an advantage when it comes to data processing, and that is they can handle missing values. You can actually specify how you'd like those missing values to be handled. Either if you want them included in the tree, or maybe you want all the missing values to be in their own separate leaf. You can decide that. And also, forest and decision trees have sort of a natural variable selection method, because as the tree is being built, it's going to automatically select the best split. So those variables that don't get included in the tree are naturally left out because they are not useful to the tree. So you can see that my pipeline is still running. Right now the neural network and both the forests are still processing. The forest just finished up. We're waiting on the neural network. In the meantime, what we can do is take a look at the variable selection output. So I'm going to do a right mouse button click on variable selection, and I'm going to go into the results. So even though the rest of the project is still processing, we can actually take a look at the nodes that have completed. We're going to open up the variable selection table, and we can see that some of these inputs, oh, I got a little message, pop-up message, the pipeline run has completed. So that's now waiting for us in the background. So we can see that some of my inputs have been included. We even have a column that's been identified as an ID. ID variables are not used as inputs because they've been identified as uniquely identifying the rows. And then we can also see that some of my inputs were rejected. And if we want to see exactly why they've been rejected, we actually have to go to a different table, because all we're told here is that the combination criterion was used. So in order to find out why a column was rejected, I'm going to close this table, and I'm going to open up the variable selection combination summary window. And you can see it's pretty cool. For the first categorical input variable, it was rejected by the FAST method. It was selected by the linear regression method, but it was rejected by the decision tree. So since it was not selected by a majority of these three methods, that particular input has been rejected. For example, if we look at the demographic of home value, you can see that that was actually selected by all three of the methods, and therefore it is included in the model. All right, I'm going to go ahead and close up my variable selection combination summary window and also close the variable selection results. Now that we know everything has been run in my project, let's go ahead and start to examine some of the results from my neural network. So I'm going to do a right mouse button click on the neural network, and I'm going to go into the results. We're going to see that we get a beautiful network diagram plot that gives us a nice visual as to how the neural network architecture was done. But unfortunately, it doesn't really provide us with any way to interpret the model. We're actually going to add in some model interpretability plots to the neural network in just a few minutes. You can also see that I have an iteration plot that is showing me how the model improves on the validation data as it continues to train. So with this particular neural network, you can see that very quickly it did some very fast learning, and then we've only made minor slight improvements as the neural network continued to be trained. We're also going to go over to the Assessment tab. And in the Assessment tab, we have all kinds of cool model assessments, but I'm actually going to scroll down and show you that we have a table of model fit statistics, and hopefully you will find your very favorite model fit statistic here. You can see, for example, we've got the average squared error, we have misclassification rate, we have the KS statistic, and I can scroll over and show you we have a whole bunch, whether you use the Gini coefficient or the tau. Hopefully your favorite statistic is listed in this table. I'm going to go ahead and close up the fit statistics and close up the neural network results. Let's also take a look at some of the results from my forest. So I'm going to do a right mouse button click on the forest, And I'm going to go into the results. And you can see we have a nice error plot. I'm actually going to expand that error plot because you'll notice there are three curves with that error plot. There is the training, there is the validation, and then there is the out-of-bag data. And so we are able to keep up with all three of those and see how they decrease as we increase the number of trees. Let's go ahead and close up the error plot and close up my forest results. Let's add in some model interpretability plots to my neural network. So I'm going to come down to my project and select the neural network to make it the active item in the interface, and then over here on the right pane you can see all the different default options that were used in order to create this neural network. We're going to scroll down in that list of options, and you're going to see there are some post-training properties including model interpretability. There is global interpretability available as well as local interpretability. So here's what we're going to do. We are going to turn on the variable importance as well as the partial dependence plots. And you notice what's kind of nice, as I mouse over each of these, you get a little bit of pop-up help in case you forget what they are. This next one is the ICE plots, or the individual conditional expectation plots. Then we have LIME, or local model agnostic explanations, as well as the Shapley values. So I've turned all of those on. I'm going to go ahead and click on Run the Pipeline. And while that's running, you'll notice what's kind of interesting is that since the rest of the pipeline had no changes, it remains the same. However, the neural network has to be rerun in order for us to get these new plots that we have requested. What is the difference between global interpretability plots and local interpretability plots? Well, what's kind of interesting about that is that global plots give you information across all of the data. So for example, maybe you're trying to answer questions like or understand if spending increases with age. So overall the data, do we happen to see that trend? Now, the local interpretability plots, of course, are more local. So they give you information about given individual observations. And by default, some random cases or observations are selected, but you can actually go in and select the ones that you want. So maybe you're trying to understand, for example, why did this one particular person get denied a loan? So the local plots focus in on the individual cases or observations. It looks like my neural network has finished running, so now what we can do is take a look at some of the model interpretation plots. I'm going to do a right mouse button click on my neural network. I'm going to go into the results, and you are now going to notice that there is a third tab of model interpretability. And there are several different types of plots, and I'm going to talk about one of them, but I do want to let you know there's a really fantastic YouTube video from SAS on model interpretability, and there's a reference for it in the PDF that you can get access to. So I would definitely check that out if you're interested in understanding a lot more about model interpretability. Why don't we spend some time just taking a look at the partial dependence plot? So one of the things that we can see here by taking a look at the variable RFM9 is it looks like that particular variable, as it is increasing, the prediction is decreasing. And we actually get some natural language processing over here that talks a little bit about that. So that's kind of interesting to see a trend across the whole data. As this one particular input is increasing, the likelihood that they made a purchase is actually decreasing. Let's also take a look at another plot. For example, let's look at RFM5. I happen to know that RFM5 is the number of products that was purchased in the past 3 years. And this is kind of an interesting chart because you can see that the prediction or the likelihood of somebody making a purchase is increasing until we get to about 5 or 6, and then it starts to decrease. So depending on how many products a customer has purchased in the past 3 years can kind of give us an idea of their likelihood of making a purchase in the future. I'm going to go ahead and close this partial dependence plot and close my neural network results. I now want to show you how easy it is to add in open source models and integrate them into your Model Studio pipeline. So I'm going to go to my project and do a right mouse button click on imputation. I'm going to add in a child node. We're going to go down to the miscellaneous category, and you'll notice there is an open source code node that we can add in. Now the reason I'm adding that in after imputation is because for open source we do want to perform imputation beforehand to handle those missing values, but variable selection is not necessary. Now I'm going to do a right mouse button click and rename this first open source code node. The first one that I want to create is a Python forest, the first open source model. I'm going to click on OK. And then you'll notice over here we can open up our code editor in the options. So I'm going to open up that code editor, and I'm going to put my mouse down here at the very end of all the comments. And then it turns out that I actually have some Python code available to me. So let me tab over to that folder. And here is my Python forest code. I'm going to open that up. I'm going to do a Control A to select all and a Control C to copy. Then I'm going to minimize that. Come back over here to Model Studio. Go down here to line 17 and do a paste. And then we're going to save that Python forest. Now I am not a Python coder, I'm not an open source coder, but I do know how to copy code. So let's go ahead and close that. And the other thing that we want to do is we're going to do a right mouse button click on the Python forest, and we're going to say we would like to move that to supervised learning. And what that does is it tells the software that this node contains a predictive model, and so it will create scored data. So you can see that now my Python forest looks just like my forest and my neural network. They all line up. Now we're not done yet. We're actually going to add in a second open source code node. So I'm going to do a right mouse button click on imputation, add a child node, go down to miscellaneous, open up open source code node. We now have a second open source code node. I'm going to rename this one as the R forest. So yes, that's right, we also have a forest built in R that we want to run. So I've done that. Now I'm going to change the language from Python to R in the options. Then we're going to open up the code editor and move down here after the comments, and just like I did with my Python forest, I actually have some R code saved out here. So let's tab over to the folder and open up the R forest code. I'm going to do a Control A to select everything, Control C to copy. Let's minimize that, come back to Model Studio, and on line 17 I'm going to do a Control V or a paste. We'll save that code and then we'll close it. And just like I did with the Python forest, I'm going to do a right mouse button click on my R forest and say let's move that to supervised learning. So that's going to identify once again that there is a model in there. All right, I've got those two set up. Let's run that pipeline and give an opportunity for those two models to run. Now, if you happen to be curious, what's actually occurring is that this code is being sent out to the server, where it's being sent to the local installation of R or Python and running out there on the server. So your R and Python installations will have to be on the same server as SAS, because SAS is not going to run Python or R code for you. We want Python and R to do that themselves. So the code is sent out to the server, it's run in Python, and then the results are brought back into SAS so that we can compare any open source models against any of my SAS models. Oh, it looks like both of them have run. That looks awesome. And one of the things that I want to do here for my model comparison node, I'm going to select that, and instead of using the default class selection statistic, I'm actually going to change that to misclassification of the event. And so we will need to rerun that model comparison node. And then after that's run, what we'll be able to do is get a nice comparison across all of the models that we have run so far in this pipeline. So the pipeline run is completed. I'm going to do a right mouse button click on my model comparison, and we're going to go into the results. In my model comparison results, the first thing that we're going to examine is the model comparison window. I'm going to expand on that. And we can see a couple of things here. First of all, you can see that the SAS forest is the model that has been designated as the champion model of this particular pipeline. We can see that because the misclassification rate of the event based off the validation data, the forest has got the lowest misclassification, and that's what makes it the winner. Now, we could have chosen any of the other model fit statistics if we had wanted to. We just wanted to change that so that we were using misclassification rate of the event. Let's close the model comparison window, and let's move over to the assessment. And you can see we have the same assessment plots that we were seeing with all the other SAS models that were being built. And so, for example, we've got a lift report. A lift shows you the lift or advantage that your model is giving you versus just picking customers at random when you're trying to find those people that are going to make a purchase. And we also have a receiver operator characteristic, or our rock charts. And right now our rock charts are showing us all the partitions. Let's set a filter so that we're only looking at the validation partition. And we can see clearly this biggest curve, the largest or outside curve, is this purple line, which happens to be my forest, the SAS forest. There's my purple line right there. So that's actually the SAS forest that is the best performer. I'm going to click on closing my rock reports and closing up the model comparison results. And I just want to take a look inside of my Python forest results. So I'm going to do a right mouse button click there. We're going to open up the results for the Python forest. And what's kind of cool about this is if you scroll down, you'll notice that there is some Python output. And of course, this is going to show the output that was created by Python from that open source code node. So you can see here is the code where it actually created a forest. based off of those settings. I'm going to close the Python output, and we're going to go over to the assessment and take a look. You're seeing the exact same assessment information of lift plots and rock reports that we get for all of the other models. So what's really nice about this is that from within one interface, we're able to compare our open source models alongside our SAS models. Let me go ahead and close my Python forest results. Suppose we don't want to build a pipeline by hand. What tools are available to us to sort of automatically build a pipeline? Well, we're going to go beside pipeline 1 and click on the little plus sign here so that we can create a new pipeline. Now, one of the features that we are not going to take advantage of that I want to show you is that we could automatically generate the pipeline. This is a really cool option that uses automated machine learning in order to dynamically build the pipeline that is based on your data. Now, this option, it can allow you to select how much time you want to allow the pipeline to generate. The only thing, unfortunately, is that it is pretty resource intensive, so we're not going to do it today. However, one of the other very nice features that are available to us is that Model Studio comes with a whole bunch of templates that you can take advantage of. So we're going to give this brand new pipeline a name of, we're going to call this pipeline from template. And down here under select a pipeline template, I'm going to click on browse, and you can start to see all of the different templates that come with Model Studio. Now what we're going to do is we're going to select an intermediate template, and we have a class target. So let's select that and click on OK, and let's see what's in that template. So I've selected my template, I'm going to click Save, and we're ready for Model Studio to build that pipeline based off of the template that we selected. So you can see we have a data node, we do some imputation and variable selection. There's a stepwise logistic regression, a forward logistic regression, and a decision tree in this pipeline. Now before we run it, we actually want to make a few small changes. So first I'm going to select the decision tree, and we're going to make a couple of changes here. I'm going to go down, and you can see that under my splitting options, I have a whole bunch of options. We're going to scroll down to the minimum leaf size, and we're going to change that from a value of 5 to 500. Now both the depth and the leaf size affect the structure of the tree. In this case, what we're doing is we're increasing the minimum leaf size from 5 to 500, which means we will have a less complex tree. And that, of course, is going to help us to prevent overfitting the model, because decision trees are pretty notorious for overfitting unless you do some pruning and work with it a little bit. I'm going to scroll down just a little bit more, and we're going to go underneath our pruning options. And under our pruning options, I'm actually going to change the subtree method from cost complexity to reduced error. Now the cost complexity pruning method, that helps prevent overfitting by making a trade-off between the complexity or the size of the tree and the error rate. So large trees with low error rate are penalized in favor of small trees. Now we actually switched this to the reduced error method. It performs pruning and subtree selection based on minimizing the error rate in the validation partition at each pruning step, and is also in the overall subtree sequence. The error rate is based on the misclassification rate for a categorical response variable, and that's what our target is. It is a binary categorical response variable. I'm going to scroll down. You'll notice that there is an option here to perform auto-tuning. And I'm just going to turn that on for just a second. We're not going to take advantage of it. But if you're familiar with decision trees, you know that there are many different hyperparameters that you can take advantage of and change. Sometimes we have no idea what to set their values to, and that is where auto-tuning can come in handy. Auto-tuning is going to automatically select values for the hyperparameters that should work really, really well by basically emulating going out and running a whole bunch of models and then finding those optimal values. Now, this is also resource intensive, and that's why we are not going to do it today. So I'm going to turn off auto-tuning. We're not going to do any auto-tuning today, and I am going to run the pipeline. Okay, it looks like my pipeline has finished running, so let's take a look at the results of the decision tree. I'm going to do a right mouse button click, and we're going to go into the results. We're going to scroll down and find the pruning error plot and open that up just a little bit so we can get a little bit more information. And we can see here that the pruning error plot shows us that the training and validation performance tends to increase as leaves are added to the tree until we get to about 36 leaves. So that is the number of leaves that we are going to use in this decision tree. Let's close the pruning error plot and close our decision tree results. And next we're going to take a look at the model comparison node. So we're going to do a right mouse button click here and open up the results of the model comparison. And we are going to see that based off of the KS statistic, because we did not change the statistic for this model comparison node, so the default that's used is the KS statistic. The champion model is the forward logistic regression model. It tended to perform the best in this pipeline. I'm going to go ahead and close the model comparison results. At some point, after you've created several different pipelines, you're going to want to choose the champion across all the pipelines. In other words, the champion of the champions. So let's go ahead and see what that looks like. We'll be able to do that from the Pipeline Comparison tab. So in the Pipeline Comparison tab, that is going to take the champion model from each pipeline and compare them against each other. And you can see here I've got two pipelines, and one pipeline, the champion was the forest model. The other pipeline, the champion was the forward logistic regression model. And you can see here in pipeline comparison that the forest model is chosen as the champion of the champions. Now, one of the things I might want to do is compare these models just so that we can see what some of the differences are. So I'm going to select both of my models and click on the Compare button. And then that's going to show me the model fit statistics. And what we could do is if we open that up pretty largely, you can see that based off of the KS statistic that the forest is actually the champion model. I can close up the pipeline comparison. I'm going to scroll down, and suppose we want to get some more model fit statistics. Maybe you're not happy just looking at the KS statistic, but yet instead you'd like to look at, for example, the misclassification rate. So misclassification rate, if we look at the validation value for the logistic regression, is about 0.151. And if we go over to the validation partition for the forest, that's about 0.14. So we can see that once again the forest is our better performing model. I'm going to go ahead and close up that fit statistics window and close the comparison window. Now right now we only have two models here. Even though we saw that the decision tree was not the best model in the pipeline, we may still want to include it as a potential challenger. Because maybe, for example, they've performed really well in the past, or maybe we just love decision trees because they're so interpretable. Let me show you how we can add in the decision tree as a challenger model. I'm going to go back over to the Pipelines tab, and we're going to go back to the Pipeline from Template, which is where my decision tree was. I'm going to do a right mouse button click on it, and I'm going to say I'd like to add this as a challenger model. Then that is going to be added in, and we're going to be able to see it as soon as we go back over to Pipeline Comparison. We'll see that we now have a third model that can be included here. There's my decision tree. Awesome. Another really useful feature in Model Studio occurs over on the Insights tab. The Insights tab gives us a summary of the work that's done in the Model Studio project, and it actually focuses in on the champion model that was selected by the Pipeline Comparison tab. So first here we get a nice project summary window. And that contains some automatically generated text that explains to us the champion model and the most important variables used. The champion model for this project is the forest. This model was chosen based on the KS for the validation partition. The 5 most important factors are RFM3, the demographic of home value, RFM2, 1, and 4. Notice also there's a nice little note for comments here that you can make to yourself about this particular project in case there are some certain things that you want to remember or you want other people to know when they're examining this particular project. And then we scroll down, we have some other really interesting pieces of information like the most common variables that are selected across all of the models. And if you ever forget what any of these little windows are supposed to tell you, there's a nice little information button that gives you some automatically generated explanations of what's exactly in this particular window. So that's pretty cool information. The next thing that I'd like to show you is let's take a look at a very quick and easy way to go ahead and do some scoring without having to leave Model Studio. So I'm going to go back over to my Pipelines tab, and we're going to spend some time on Pipeline 1. And since our forest model was the best performer, let's actually do some scoring there. So I'm going to find my forest model. I'm going to do a right mouse button click to it. We are going to add a child node. We're going to go back to that miscellaneous category, and we are going to say that we would like to score some data. So just for this one node, we're going to do some scoring. For the score data node, you'll notice we have some options. Let's pick the table that we want to score, so I'm going to click on Browse. And I'm just going to score the original table that was used to create all these models, just to make things easy. We'll click on OK. And then we need to specify where we want to place the scored data. So under Output Data, I'm going to click on Browse. And here on the CAS server that's available to me, I'm going to drill down and move into the CAS user library, which is available to me. I'm going to select OK. And then I'm also going to turn on the checkbox that says replace existing table, just in case there's an old table out there with scored information that we want to overwrite. I'm going to run that pipeline. And then this is just a very easy way for me to perform some quick and easy scoring without having to go anywhere else. In just a minute, I'm going to show you a little bit more sophisticated way to score your model and also really to manage your model completely. So let's let this scoring run and give us some scored results. Okay, the scoring has taken place, so we're going to do a right mouse button click on score data and go into the results. And we're actually going to move over to the Output Data tab, and we're going to say that we would like to view the output data. We're not going to enable sampling, we're just going to view the data itself. This is a relatively large table, because remember, in the original table that we used to create these models, I think it was about 500,000 rows is what we saw, and almost 30 columns. Well, remember, once this scoring has occurred, we've actually added in scored columns of data. So this table is going to open up for us, and we will be able to scroll over and see that scored data. All right, my table is open. And I'm actually going to scroll across until we find, there we go, I'm starting to see our scored columns. That's perfect. So here we have the classification, we have the event probability, and we have the probability. And so those are the scored columns that have been added. We also get a couple of other columns, the into column and the predicted value that B underscore target is a 0, and the predicted value that B underscore target is a 1. Let's close that table. Now let's do something a little more sophisticated to manage and deploy our models. I'm going to go back to the Pipeline Comparison tab. And remember, that's where my 3 models are. Well, I'm just actually going to select 2 of these models. I'm going to select the forest model. I'm going to deselect the logistic regression, and I'm going to select the decision tree model. Then I'm going to go to this upper right-hand corner overflow menu, which is the project pipeline menu, and say I would like to register those 2 models. We're going to register them in the default location. And now what's happening is information from both of those models is being moved from Model Studio into another Viya application that's called SAS Model Manager. So a whole bunch of important information about those particular models is being moved over. And SAS Model Manager really allows us to streamline the managing and deploying and monitoring and operating aspects of using our analytical models. It allows us to maintain a repository of both SAS and open source models for analytic and analytical projects. The repository really allows us to easily compare our registered models, and it also has tools to allow us to monitor the performance of the production of models. Now, you know that many times as time goes on, that models tend to degrade. So you can actually keep track of that. You can retrain your models. You can redeploy them. Basically, with SAS Model Manager, there's a really great way to automate and streamline the entire analytics lifecycle so that your models get into production faster. Both of my models have been registered now, so I'm going to click on Close. And then we are going to move from Model Studio into Model Manager. So I'm going to return up to the upper left-hand corner Applications menu. And this time, instead of building models, we are going to manage models. And that's going to take me into the first projects page of Model Manager. Now you'll notice I have 2 projects here that have been registered. So I've been doing my homework. I actually had a backup just in case we had problems with our particular project, but let's go ahead and use the Model Studio project that you and I just created. So I'm going to select it to open it. And then when we open that up, you'll notice that there are 2 particular models that have been registered. We have the decision tree and the forest model. You'll also notice that the forest is defined as the champion model. Now, let's suppose there's a particular reason that you want to select one of the other models to be the champion model. That's very easy to do. You can select the model that you want to set as the champion model. And then here from our Actions menu, you can say I'd like to set that as a champion. Now, we're not going to do that because we're going to leave the forest as our champion model, so we're going to just leave that alone. But what I am going to do with the forest model is I'm going to select it, and then in the very upper right hand corner we have another Actions menu that will allow me to retrain that model. So what we want to do is we want to retrain that now with a brand new data table, and I'm going to select that table. Once again, we're going to use the same table that we used to build the model. In the real world, we probably would have a brand new table that we would use in order to retrain this. And then we click on Send, and then that's going to run in the background. So that's running in the background, and when Model Studio pipeline finishes retraining that retrained model is going to be put into a new version, for example version 2, and that way we won't get it confused with the current model, so we'll actually have separate models. Now while that's running, let's go ahead and finish things up by looking at one more of the features of Model Manager. So I'm going to navigate back here to the Models tab, and you can see that we have a total of 4 models, and that's because I've got 2 from my backup and 2 that you and I created. And what I want to do is I want to create the forest. I want to select the forest that you and I created today. So I'm going to select that forest and drill down. And that's going to show me a whole list of files that are associated and available to us. And I just want to point out a couple of these. The first one I want to point out is the one that's called dmcas _ ep scorecode.sas. And this is actually SAS code. It's base SAS score code that's written in DS2 or Data Step 2. And that can be used to deploy this model anywhere that SAS code can be executed. There's also another piece of code called dmcas _ package scorecode.sas. Now this is a score code that's packaged slightly differently, and it can be used with SAS Microanalytics Service if that's available to you. I'd like to thank you for taking the time to join me on this journey through the analytics lifecycle using SAS Model Studio. If you have any questions, please feel free to contact me. Otherwise, see you next time.